Hello everyone, or just me, if I'm the only one watching this. So I'm putting together this video to help with my revision. So when I study, I like to grab cool insights from all over the places like videos, articles, and quotes, you name it. But without proper revision, I often end up forgetting a lot of it. So here is my attempt to tackle the learn, forget cycle. So today, let's dive into the linear regression. Ever heard of it? So linear regression is a supervised machine learning algorithm where we predict the continuous values that have a constant slope. Think of it as a tool to forecast numbers like sales or prices rather than categorizing like things cat and dog. So here is this equation. Y is equals to mx plus p. You might have seen this equation in your linear line class or mathematics class. So how do we represent the y is equals to mx plus c? So this is the graphical representation. Here is my m and c. When I change my m to a little bit more positive value, the slope changes, and when I change my c, it changes the intercept. For example, like I'm making 3.05, it's a 3.05 value. All right, so you can play along with me with this equation setting. All right, I'm back to the linear regression. So we will be coming back to multi-variable regression when in the next video. So here is a simple example of company radio sales. So company, there's a list of company name, radios, and what we have to predict is sales. This sales. So make prediction. So you saw this equation y is equals to mx plus p here, and this is again a similar equation. You might not be able to recognize it, but sales here is the y, weight is the m, and the constant is the bias. So what is weight? What is bias? What is it? So let's come here to the visual representation of a linear regression. It's not working. Let's refresh it. So here is a simple representation of a linear regression example. Consider them as 2 points for the sales value. And this is my line. I have to assign weight and bias such that my line fits best according to these points so that my squared error is minimum. So when I change my weight, it's going up, down, and this. So when I change my bias, it's changing the intercept. So what is here? What do you learn? That way we have to assign weight and bias such that the line fits best according to each and every point here in my. So you can read this remaining article from this site, immense cheat sheet, and I will also be giving credit to the fantastic sources where I have picked up this knowledge. For example, this ML cheat sheet and this GeoGebra graphical representation. So I told you that the equation y is equals to mx plus b. So it's a simple equation, but our teacher Andrew Ng teaches in another language, he's not teaching any alien language, but there is a term called hypothesis. You might have heard this from your professors. Hypothesis, and all right, hypothesis theta naught plus theta 1 x. So theta naught is my constant here, and theta 1 is my slope. So many the professors and the people from where we learn uses this the hypothesis. Don't get confused. So theta 0 is our bias variable and theta 1 is our weight variable. So hypothesis is our prediction of how the curve might look. So this is the definition of hypothesis. So coming back, so I'll make you understand how we are getting this formula to calculate the slope. So what is the formula for slope? M is equals to summation of xi minus x mean into yi minus y mean by summation of xi minus x mean. So how we are getting this? So I learned this from a YouTube video. I'll mention the link in my bio detail section on my YouTube. So here we have this regression line with points like this. Consider them to be x1 and y1, and consider this point to be x mean and this to be y mean. So this is my x mean, y mean. Okay, all right. So to calculate the distance from this point to this point, what we have to do is x1 minus x mean and y1 minus y mean. So we will get the points. After calculating the area, what we are getting x1 minus x mean into y1 minus y mean. So this is my area for this rectangle. And when I go back and see the formula, it's actually here. It's the area of this rectangle on the numerator. So when I see this denominator, it's actually xi minus x mean whole square. But when I come back to this graph here, what I've done here is I've aligned all the points to the main regression line, and such that the rectangle that was formed above here is now a square. It's actually going to be a square when my points are on the regression line. All right. So now when I calculate the distance, it's going to be same from the both sides, x1 minus x mean. And when I calculate the area, it's equal to x1 minus x mean whole square. It's on the denominator part. So what we are calculating here as slope is area of rectangle, sum of areas of rectangle by sum of areas of square. It's generally what we have is the area of rectangle is lesser than the sum of area of square. So it's my value goes from 0 to 1, but I say generally, not every time. So this is all about the derivation of the slope, how we calculated slope from the areas of rectangle and squares. All right. So I'm making these videos for my revision. If you like these videos for your revision too, you may continue watching them from my YouTube channel. I'll be mentioning the link here.